In today's lesson, we will be discussing how to find derivative of inverse trig functions. And we're going to combine all those together with the chain rule. And so as you can see, this unit has a lot of rules that you will need to know how to apply. But derivative of inverse trig functions, derivative of trig functions, derivative of logs and exponential, those are things that you can memorize, and it will take time to memorize all of those. I know that a lot of you have memorized all the trig derivative already, and that's a good sign. So continue to review your lesson, your notes from time to time, so that by the time the exam comes, you have all those formula memorized. Now, there are 6 inverse trig functions, and here are its derivative and how to represent them. The first inverse trig function is gonna be the sine inverse. So derivative of sine inverse. Another way to represent sine inverse is to say derivative of arc sine. That's another expression for sine inverse. And the answer to its derivative is just 1 over the square root of 1 minus x squared. Okay, 1 over the square root of 1 minus x squared. Second inverse trig function, we're going to focus on the function cosine inverse. Also, another way to represent cosine inverse is to say arc cosine, like that. And its derivative is gonna contain a negative symbol. Okay, every time you see a derivative of any trig function that starts with a letter C, will have a negative. So it's gonna be negative 1 over the square root of 1 minus x squared. As you can see, it is very similar to sine inverse. What's the difference? Well, the cosine inverse contains a negative, and that's the only difference. The third inverse trig functions is the function tangent inverse. Tangent inverse. Another way that we express tangent inverse is we call it arctan. Okay? And its derivative is actually very easy to memorize. It's just 1 over 1 plus x squared. Okay? And sometimes you might see people write it as 1 over x squared plus 1, but they are the same expression. So keep that in mind. So the first 3 are very important. Now the last 3, I want to make it known to you out there, and you will need to memorize the last 3, but they're not as important as the first 3, because the last 3 can be derived if you know the first 3 inverse trig functions. So arctan, its derivative is negative 1 over x squared plus 1. That's the fourth function. The fifth function, the derivative of secant inverse. Another way for us to express secant inverse is arcsecant. Its derivative is 1 over the absolute value of x times the square root of x squared minus 1. Okay? And the last guy, the derivative of cosecant inverse, we can also write that as arccosecant inverse. And its derivative is, guess what? It's very similar to the one before. What's the difference? Well, because it begins with letter C, it's going to have a negative, right? Negative 1 over the absolute value of x times the square root of x squared minus 1. Okay? So those are the derivative of the 6 trig functions, inverse trig functions. Memorize the first 3 at the very least, and then memorize the next 3 4, 5, and 6 later. But now make sure you memorize these 3 trig functions so that you can be ready to conquer the challenges of Unit 2 exam. Alright, so these are their derivative. I'm gonna have you apply the derivative and the chain rule together. If you still need extra help with the chain rule, remember to figure out and distinguish between the outside and inside function. That's gonna really help you apply the chain rule correctly. So find the derivative of sine inverse of 7x. I look at this and I know that there are 2 functions. This is the outside function, and then this is the inside function, which is 7x, right? Chain rule says, what does it say? It tells us to start with the outside function. So I'm going to start by taking the derivative of the outside function. The derivative of sine is 1 over that, okay? So we go 1 over the square root of 1 minus whatever was originally inside the parentheses, and that is 7x, okay? And the chain rule says once you finish with the outside, then multiply that with the derivative of the inside, which is 7, and you're done. So using the chain rule, we know that the derivative for that particular example is 7 over 1 minus 7x. Done. Alright, let's go ahead and try to find the derivative of example number 2. I'm going to zoom in a little bit so that you guys can see better. Okay, now this just means the inverse of cosine, and there are 2 functions in here. Identify the outside function first, which is the inverse cosine, and then your inside function, which is e to the x, right? And then maybe to the right, write down chain rule and apply the chain rule, which says take the derivative of the outside function, and we know that is equal to there has to be a negative, right? 1 over the square root of 1 minus whatever was originally inside that parentheses, and that was e to the x, times it by the derivative of the inside, and the derivative of e to the x is e to the x. So if we just clean this up, we get negative e to the x over the square root of 1 minus e to the x. And I hope that was not too bad. Here's another one, arctangent. Okay, outside function is tangent inverse. Okay, the inside function is the function ln of x. Okay, so we apply the chain rule because there's an outside and there's an inside. Start with the outside function. The derivative of inverse tangent is 1 over 1 plus whatever is in the parentheses, and that was this, and we have to square it, right? That's what the formula says. Times, so we took the derivative of the outside, and now we go on and we find the derivative of the inside, which is 1 over x. So we finally write our simplified answer. We can move the x to the front. I put parentheses around the 1 and the ln square. There you go. Okay, great job. The derivative of x over tangent inverse of x. This is a quotient problem, so we have to use quotient rule. Okay, so use quotient rule. Quotient rule. Why don't I label my high function first? So my high function is the x function, and then my low function is the tangent inverse. Okay, and then the derivative of the high function is 1. The derivative of the low function is 1 over 1 plus x squared. All right, and then remember what the quotient rule tells us. it tells us that we go low d high, all right? So low times d high minus high times d low, If you multiply those together, you're going to get something like this, over low square. So this is low, and then we square it, and we're done. That's the derivative. This hopefully makes using the quotient rule easier than just to memorize the formula. All right, the last example, guys, this is the product rule, because we're looking at the product of two functions. So product rule, call the first function f, and that's x. Call the second function g, and that's the inverse of sine. So f inverse is 1 and g inverse, according to the formula that we have established on the other side, it is 1 over 1 minus x squared. Now we're ready to apply the quotient rule. The quotient rule says take the derivative of the first function times the second function. So I multiply these together, and then I add it to the product of these. Okay. Sine inverse of x, when you multiply this together, you get sine inverse of x plus, and then multiply these together, which equals to x over the square root of 1 minus x squared. You're done. Great job. You have just gone through the lesson on the derivative of inverse trig functions. Notice that I used the first 3 and I did not use the last 3. It doesn't mean that you won't see it on the AP exam. It just means that these are the more commonly used. So out of these 6 trig functions, memorize them all, but memorize these first 3 now, and then these will hopefully come later, and might as well do it now.